Here we're asked to find the components when we are given the magnitude and direction of a vector. So in this case here, I oftentimes think it's helpful to sketch it out and then deal with it from there. So to start, I'm going to do this first one here where the direction is 115 and my magnitude is 4. So remember with the direction, I'm always starting from 0 degrees. So 115 starting from this direction here is past 90 degrees, but not all the way to 180 degrees. So when I do this problem here, I'm going to go ahead and kind of sketch it like that. What's really important here is if I were to like zoom in on this triangle that I just created, if I were to kind of see the angle here between the y-axis or, the straight vertical component and the line itself, our magnitude here of 4, that angle is going to be 115 minus 90. So that angle has to be 25 in this situation here. It's very helpful because now if I'm looking for vertical and horizontal components, this is just a right triangle. And to solve for that, I'm just going to use SOHCAHTOA or sine and cosine. So for the horizontal, I'll start with the horizontal component first. I'm saying sine of 25 is equal to the opposite, which is my horizontal component, over the hypotenuse, which is my magnitude. So my horizontal component really is just 4 times sine of 25. Same idea for the vertical component, except that I'm dealing with cosine because I want the adjacent side of the angle, 25. That's equal to the adjacent, which is my vertical, over the hypotenuse, which is 4. So 4 cosine of 25. Now, the thing that I want to make sure to understand here is that I'm going to plug these numbers into a calculator and I'm going to get some values. So 4 sine of 25 is, I'm going to round this to about 1.69. But the horizontal component, look at this. We got to look at this because I'm going to the left, right? My horizontal component is this way here. So that means that my horizontal component needs to be negative. My vertical component is going up, so that's just going to be a positive value. If I do 4 times cosine of 25, I get 3.63 as a rounded value. And so here is my final components. And if I were to be asked to diagram that, right, I would want to kind of match up. So a little over 1.5 to the left, and then 3, actually I should go down here. So if I'm starting here, 1.5 to the left, and then 3, 1, 2, 3.5. Again, maybe right here. Oops, right here. If I were to try and sketch this out as a vector, but again, I'm just using sine and cosine because I can create a right triangle. So same idea with this one here, do it in blue instead. I'm going 230 degrees. So if I'm thinking here, that's over 180, but not all the way to 270. And that gives me my vector. When I have this vector here, again, if I want this angle here, I'm going to subtract 230 minus 180. So once I do that, that gives me this angle, which is 50 here. And now I can, looking for the horizontal and vertical components, use sine and cosine. So from here so this is where it gets a little bit tricky because sine and cosine don't always necessarily represent the x or y values in this. It just depends on how you draw your angle. In this angle here, different from the last one, the way that I drew this, my horizontal component is my adjacent side to this angle. So what that means is that when I'm trying to solve for the horizontal component, I'm going to say cosine of 50 equals the horizontal over my hypotenuse, or the magnitude. So in this one, horizontal is going to be 8 cosine of 50. So it's cosine this time and not sine like the last one. Then for the vertical component, I'm using sine because it's opposite of the angle. So I'm saying sine of 50 equals my vertical component over the hypotenuse. I multiply both sides by 8, and I get 8 sine of 50. Oops. And in this situation, you should see that I'm going to the left and down, meaning both of these components need to be negative once I plug them into a calculator. So once I plug these in, I got 8 cosine of 50 is about 5.14. 8 sine of 50 is about negative 6.13. Again, I'm making it negative because of my direction, not because of what I'm getting in the calculator. So from here, that's my final components. If I were asked to sketch this out, I'm going to go 1, 2, 3, 4, 5 and some change, down 1, 2, 3, 4, 5, 6 and a little bit more. And so this is my sketched diagram. And again, the nice part about having the components is I don't even really need to worry about this direction of 230 because it automatically, that should be 230 degrees if I sketch my values right.